Hi, I'm Tony from oddwires.co.uk. Today I just want to take a few minutes to show you a home security system that I've been working on. The design concept is, it's an upgrade to an existing home alarm system. It should be controlled and monitored remotely over the internet through an iPhone interface, so when I'm out and about I can make use of Wi-Fi, internet or 3G. As it's an upgrade to an existing system, it has to reuse the existing door switches, PIRs, alarm boxes and cabling. This means the whole system needs an industry standard 12 volt interface. And I want email alerts sending directly to my iPhone for changes to the alarm status or network connectivity, particularly thinking about changes to my router IP address. And I don't want to be waiting up to 15 minutes for my iPhone to pull alarm emails from a server. I want them pushed to the iPhone as soon as they are sent. This is achieved using iCloud email, which pushes to the phone. At the phone, the system emails are recognised as VIP mail, which triggers the iPhone alarm sound. I'm using this particular sound as it's loud and it's long, so if the alarm triggers in the middle of the night, it should wake me up. I also require the system to replace a number of mechanical timer switches that have been used around the house to control lights. This has been achieved by interfacing to an off-the-shelf radio control switch system. And I want to be able to schedule tasks, to set the alarm, control the lights, and check the router IP address for changes. So this is the hardware interface. It consists of a standard off-the-shelf remote control handset for the remote switches, the handset interface, which picks up power and data, so no need for batteries in the handset, a small 5-watt amplifier to look after door chimes and the internal sounder, alarm circuit inputs through standard screw connectors, GPIO header to connect to the web and application server, and the alarm outputs for the bell boxes, strobe and internal sounder. Now the web and application server is a standard Raspberry Pi. The photo shows the early revision 1 unit, but the software will run equally well on either revision 1 or revision 2 boards. And then the whole thing just fits into a standard plastic enclosure. So let's have a look at the system working. So here we have a terminal connection to the Raspberry Pi, which is providing the back end to the system. This is a Linux operating system running Apache, PHP and a Bash shell script. The Bash shell script runs in the background and forms the alarm service. This alarm service auto runs at startup, so the system doesn't need a screen or keyboard, but for this demonstration I've started the terminal session and I'll stop and restart the alarm service, as this is the easy way to grab the output and shows the dialogue between the web page and the shell script, which just helps demonstrate what's going on. So there's the alarm service starting up. And the log tells us just here that an email has been sent. Now, system restart would usually indicate a power failure or other hardware problem, so it's something I'd want to know about. There's the email just arriving at the iPhone now. I'll just mute that. So that's restart email mute. So every change to the settings that affects the alarm status will trigger an email, and you'll hear these arriving as I work through the various options. So moving across to the iPhone interface. This has been built around JQT, which is a jQuery plugin that takes a regular web page and gives it the look and feel of a native iPhone application. So when I browse to the system, I get the logon page, and as you would expect, access is password protected. Now immediately we have a feature here. Often I just want to have a quick peek at the status to check everything is okay, so I don't necessarily want to have to log on. So there's a status button just up here in the corner, which gives us a quick overview of the alarm and the individual zones. It's a read-only screen, so it's not possible to affect any of the alarm settings from here, which is why I've left it visible outside of the main logon. So let's log on to the system. Now, as we log on, you can see here on the Linux box, the event gets recorded. So we have the time, the login ID, the IP address of the iPhone and the event. And here on the iPhone screen we get the main alarm control panel. Now the top section of this screen allows control of the alarm status, and the lower section allows configuration of the 8 alarm zones. So from here I can change the alarm mode. I can choose from full set, part set or standby. Now these modes are similar to those found on commercial home security systems. Sometimes full set and part set are referred to as day mode and night mode, but unlike a commercial system, we don't have an engineer mode. This is because once we're logged on, we're already in engineer mode. Another conventional feature that isn't required is entry and exit zones. This is because we're operating the system over a Wi-Fi, so we can just exit the property normally and arm will disarm the system from outside. So from here, I can reset the system, or I can test the external siren, the external strobe, or the internal sounder. And there's the reset email arriving now. So reset email mute. Now the system has 8 zones, all of which can be individually configured. So for instance, on zone 1, I can change the name of the zone to something a bit more user friendly. So let's set it to front door. And it updates immediately. I can also enable the zone in full set, part set and chimes. And the green indicator shows the current configuration. Another option will be to configure the zone as a tamper circuit. Now when a zone is configured as a tamper circuit, it is permanently active. So the full set, part set and chimes options become meaningless, so just aren't available. So this is where it's about to get a bit noisy, so I'm just going to mute my iPhone for a minute. Now, as you can see, the circuit was open, so the zone immediately triggered and the alarm system was activated. Resetting the alarm won't clear a tamper alarm condition, it just keeps re-triggering. This is indicating a hardware fault with the cabling, or if you have a fire alarm connected, maybe your house is on fire. Either way, you need to sort it out. So we have to set the zone back as an alarm circuit before we can reset the alarm. So having seen the tamper condition, let's have a look at an alarm condition. So if we set zone 1 to be active in full set only, and we set zone 2 to be active in part set only, and we'll set zone 3 to be active in full set and part set. Now the alarm is still in standby, so nothing happens. So if we set the alarm to full set, zones 1 and 3 trigger and the alarm activates. This time, because this is an alarm condition, we can clear it by resetting the alarm. Note that the reset sets the mode back to standby, which prevents the zones from re-triggering the alarm. So now if we set the mode to part set, this time zones 2 and 3 trigger and the alarm activates. And reset that. So that just about covers the alarm screen. So let's have a look at the next screen. So this next screen controls the remote switches. The alarm system interfaces to an off-the-shelf remote control transmitter. So our channels 1 and 2 connected to lights in this webcam window. So as you can see, remote control channel 1 on, remote control channel 2 on, remote control channel 1 off, remote control channel 2 off. Now, just as we're able to customise the alarm zones, we can also customise remote control channels. So let's give these 2 channels a couple of user-friendly names. So remote control channel 1 becomes the left light, and remote control channel 2 becomes the right light. So now we have left light on, right light on, left light off, right light off. And the next screen is where it all starts to come together as an integrated system. This screen allows us to set up scheduled tasks. It just taps directly into the Linux cron tab file, which isn't particularly user friendly, so I've put a couple of web pages around the interface to make it accessible over the iPhone. So to create a new task, we start down here with a new task button, which takes us into the editor screen. Now I don't want to spend too long on how cron jobs work, so I'll just run through a couple of quick examples. Suppose we want to set the alarm to full set at 10 AM. What we would do is hours, 10, minutes, 0, task, alarm full set, and save. And there's a new task created. Then suppose we also want to turn the right lamp on at 9:15, but only in March. So what we do is hours, 9, minutes, 15, month, March, task, right lamp on. And with the tasks, note that task list has picked up the user-friendly names that we've just entered on the previous screen. And save that, and there's the new task. And while we're on this screen, there's another task which I use a lot more than the others, and that is every hour, on the hour, check the router IP. And what that does is it sends a ping off to an external website, confirms my local router's IP. The external site doesn't like more than one ping every 5 minutes, which is why I set it to hourly. If the ping returns the same IP, the task does nothing. But if the router IP has changed, the system will send me an email informing me of a new address. I've been running the system for 5 months now, and the IP hasn't changed yet, but if it does, I'll know about it. So we're finished with the webcam, let's get rid of that. So this next screen provides some very basic user admin. New accounts can be created, existing accounts can be edited. Each account has the option for an email address, and these addresses are used to create the circulation list for all email alerts coming from the system. This first account is sending emails to an iCloud email address, so these emails are being pushed to the iPhone as soon as they are sent. The second account is sending emails through a conventional email address, so these emails aren't being pushed and will arrive at Albert's iPhone at 15 minutes intervals. Obviously a lot can happen in 15 minutes, so I prefer the iCloud email. And the final screen looks after all the program parameters. So we can set the location name or control the alarm duration. And down the bottom we can enter the details for the email account being used to send the emails. So we've got 5 screens, all full of settings, and it would be incredibly annoying if the system was rebooted and we were to lose the lot. So this screen also allows us to save and load defaults. So I can reset the system to the factory defaults. Bink. And as you can see, the email settings are gone. The alarm zones have gone back to generic names, as have the remote control channels. And all scheduled tasks have been deleted. It's probably worth mentioning that the user accounts aren't affected by the defaults. So now, if we load the user defaults, the email parameters come back. This time we have a full set of alarm zones, and each zone has picked up its own individual configuration options. The remote control channels have brought their names back, and we have a full list of scheduled tasks. And that's it. That's pretty much all about the system and how it works. If you'd like to know a bit more about the hardware or the interface board, I have a website, oddwires.co.uk. There's a lot more detail, some circuit diagrams and further explanations. If you'd like to have a closer look at the code, there's a full copy on the GitHub. Just go to github.com and search for Oddwires. And if you want to get hands-on with the software, you can. The alarm service and web application will run without the interface board. So if you have an iPhone and a Raspberry Pi, you can build this system in just over an hour. All the alarm zones will show as permanently open, and the remote control channels won't do anything, but you can still evaluate the software and the interface. There's a full set of build instructions which will take you right through the 19-step build process available on the oddwires.co.uk website. So this has been Tony from Oddwires. Thanks for watching.